Hi everyone. Um, I'm going to speak about a subject that may seem like a boring title after all those fun talks about VR and other very cool subjects. But for me, it's a very important subject as a quality and making things actually work for a long period of time, without having to go back to production bugs, and makes us being able to go to the fun parts without having to go look back all the time. So, I'm Noam. I work for Wix. Wix is a platform for building websites. We are based in Israel, but we also have engineering locations here in Kyiv and in Dnipro, as well as in Lithuania. I work on something called the Wix Viewer. I will explain a little bit more about that. But about me, I was working on Frontend on and off in the last 20 years. The first meetup I went to was about new technologies, CSS and XML. They kind of stayed since then. I also worked in the browser business. I worked at Nokia in building browsers and on the WebKit open source project. So I saw how software was done in other places outside Frontend and how we were supporting all the front-end engineers by creating browsers with less bugs and more features. I also, with all the testing we had at WebKit, I one time ended up breaking YouTube in the nightly build anyway. So, okay, I work for Wix. Wix is not such a small company, but I work in the teams that builds the Wix editor and the Wix viewer. Are people here familiar with Wix, with what we do? Here and there, yeah. So Wix is a very popular editor for building websites. It allows people that are not necessarily technical or that are at varying degrees of technical level to have an online presence, like carpenters, healers, yoga studios, photographers, restaurants. Anybody can have their own website without having to go into the details of hosting, of React versus Angular. They don't need to think about it. They just need to think about their own business and how to design it and make it nice. So the Wix editor is actually two technical products. One of them is the editor, is the UI, all the drag and drop, all the panels, the big web application that allows you to edit. The other one, which is less apparent, is the Wix viewer. The way the Wix architecture works is that the editor doesn't save a full HTML website. What it does, it saves like an edited model, like a JSON, like a big model of your site, of every decision you made as a website editor. Like it's going to say, there's a picture of an ice cream over there, there's going to be a title over there. And those are Wix components. They're not like an image can have maybe a few divs and an image inside of it with a preloader. It's not just, those things inside the Wix JSON are not HTML components, are high level, and what you are able to edit inside the Wix editor. What the Wix viewer does is take that model and display it on the user's browsers. So we have this big JSON, and then for every user that goes into the ice cream website, they will get the JSON, and they will get a bunch of JavaScript libraries that will present it and make it into DOM and to something that the browser can render, and with all the CSS you need, makes it into a real web application. So Wix components are complex. I'm gonna talk about component testing. So I'm gonna start with talking a little bit about our components. It's customary to look at components as something simple, but I see components as something quite complex, and they definitely are for Wix. A component is not just something we render on the screen. It has to interact with the user, like with events, like scrolling the screen, clicking, touch events, depending on what the component does. It has to deal with the network sometimes, with services, like Facebook Like is one popular component we have. It has to interact with the Facebook APIs and get new data. It has to, now we have something new called Wix Code, which allows users to interact with Wix components using simple JavaScript. So our components need to interact with those interfaces as well. And we have a whole bunch of internal systems like BI events, business events, and A/B testing. Maybe we want one component to look different for different users while we're testing new features. So Wix components are complex. Internally, in the architecture, we use React and Mobix. So we use React to take all those states and data model from editing, what's happening right now in the code, what A/B tests we're running right now, and turn that into the current DOM. We're heavy users of React. And we use Mobix to, you can say like an optimization, to make sure that we only render the components that need rendering. And Mobix helps us react to changes and have a store that makes only some components render rather than others. Also, we use as much as we can TDD, test-driven development. It means that when we have a refactor or a new project or a bug fix even, we first write a test for it. Are people here familiar with test-driven development, where it comes from? Yep. In the browser world, we didn't call it that, but we were using it all the time. We had to first write the failing test, and only then write the production code for it. So we're very keen on test-driven development at Wix. With component and UI, this is actually difficult. I've seen a lot of challenge with it. Our natural way of dealing with a UI problem or front-end problem is to try it out in the browser, see why it doesn't work, open Chrome DevTools, kind of try to change a few things in the CSS in Chrome DevTools, and then, okay, it works, I'll pass it on to QA. So it's not very easy to, it's not very intuitive to TDD frontend, and I see many frontend developers try to avoid it, or try to go there and then, no, I'm not going to do it. So in this talk, I'm not going to show production code at all, but only tests of a simple component, because the tests also tell the story of how the component is built. Let's take a simple component. I see that the video is not working. Okay. Let's see. Yes. So the video stopped working from moving this presentation to a different computer. But let's imagine the component we need to build. Okay. So the component we need to build is the simplest one we have. It's called the back to top button. So it's a button that when you click it, it scrolls all the way to top. It scrolls your page all the way to the top of the page. When we're working with a product owner, they actually define quite a set of requirements for this little silly button. So it only appears when you scroll up, because it's a button that helps you scroll back up quickly. If you're scrolling down, you don't want that button to appear. It will just bother you. If you start scrolling down, it will disappear, even if it did appear. It wouldn't appear when you're already pretty close to the top. You have to be at least 1,000 pixels farther from the top. After 1 second, it will fade out if you're not doing anything, because maybe you just want to read the content. You don't want that button to be in your way. And it only appears in portrait mode, like this. If you rotate the screen, it would not appear. The reason for that, just a decision, a product decision. A lot of the product decisions are just about trial and error, and that was a decision. So all of these are requirements of back to top button. And we use React to create it. So naturally, we will start testing it. This was our original way of testing things for the Wix viewer. We would use the React test utils and the React testing tools, and we would try as much as possible to treat it as a unit and write unit tests for it. Here's the little back to top button. That's how that bastard looks like. So this is how a test for our original tests for a back to top button component would look like. It's pseudocode-ish, because I didn't want to put a whole bunch of boilerplate in there. But we use something in React test utils called render into document. I looked at the code inside render into document. What it does is actually creates a memory leak where it renders the component into an empty div and saves it inside React. So if you render 1,000 components with React test utils, you will have 1,000 components in memory, even though they're not accessible to you. That's one issue. But if I look at how I would test it, I render it into the document, and then I check the class name. The class name is equal hidden. And then I can't really scroll in here. I'm not, like I said, I'm in JS DOM. It means I'm in a node environment. I'm not in an actual browser. I created a fully encapsulated node environment, and I rendered my component inside of it. So I can test the class name, but then I can't scroll the window. So what I do, I expose an API to the button that's on Windows scroll, and I call that one. And then I check the class name again. Now this repeats itself, and then I wait for 1 second and check that it's hidden. Now, what is the problem with these tests? Is that I had to manipulate my component for the test. I had to create a function that I wasn't going to otherwise expose called on Windows scroll. I'm not testing that it's actually doing something on scroll. The other problem here is class name. If I wanted to change the implementation of this component to not work with class names, but work in a different way, I would have to rewrite the test. So at the Wix viewer, we found that many times when we write very specific unit tests to implementation of a component, we end up with tests that are too specific, and we end up having to rewrite the test every time we change a little thing about the implementation of the component. So one thing we do like about the technique of using Node with JS DOM is that it's fast and stable. Because we encapsulated all the tests into something that's pure Node, pure functions, doesn't deal with the browser, doesn't deal with timing as much. These tests are really fast and really stable, and are not flaky at all. The problem with them is that the component becomes a white box. We need a whole bunch of hooks into it. We're no longer testing what the component is meant to do, but rather we're testing the interface that we created for this component. What a lot of people end up doing in this, to address this with React, is that they create higher order components. Like we create a React component that you can test in this way, and then above it something that that talks to the DOM and to all the events and to timing. But what we saw many times is that all the bugs happen in the above component, in the component that doesn't have the tests, like the integration between the component and the outside world. With this type of testing, we see spies and mocks everywhere. We see like trying to pretend to React that we're currently in a browser, but not really. What I do today when somebody gives me a code to review that has a spy is that I reject it. I personally decided it in the last year that I'm not going to use spies for anything. Spies usually mean that your interface is not right, or that your interface can be better. It means that you have some sort of a monolith, a unit that is not really a unit because it relies on other things that you have to mock. So my standard response to I have a mock or a spy, can you review this, is rethink your interfaces, rethink your API design, rather than trying to solve it as a test. This is also why TDD is important, test-driven development, because it makes you think that way. Usually when I see code with spies, it's because it wasn't written with test-driven development. You have existing code, and you have to put a very thin pipe into it to get to all the parts and test it. Every time I see code like that, it makes me think of colonoscopy. Anyway, so we get HOC inflation. So with unit test, we end up not testing much. Selenium. Selenium is very popular way of doing end-to-end cross-browsers testing. This is how a standard end-to-end test with Selenium looks like. We go to some site with a back-to-top button. We check if it's visible. Selenium has really nice testing framework style functions like is visible, which tests many things. The button can be visible using the display none, made invisible using display none or visibility hidden. This doesn't test opacity, but that's okay. So we don't care here how we, excuse me, we don't care here about the implementation. Did we use class name? Did we just change the style? Do we have some CSS cascading thing that made it disappear? Does it have a parent that disappeared? We don't care, we just care if the button itself is visible or not. I like that a lot. It's much closer to the user. So we have the same tests here. My main issue with this test is the first line. It doesn't connect with the code. This test relies on having a real server with the real website with the back-to-top button. Of course, you can write tests with Selenium that are more connected with the code, but this is the more natural way to work with it, like end-to-end. This is more how the Selenium APIs take you towards this type of test. So Selenium tests do test the feature. They're a little bit icky to set up and use. And the problem with them is that they usually end up testing too much. You need to have a server, you need to have the whole thing just to test them. So it's high value with high cost. With Karma, Karma is a framework that the tests run inside the browser. So we can use all the different in-browser JavaScript APIs, which is much nicer than doing it inside the node closed environment. Now this is a very nice test. I can check the computed style of my component. I can scroll within the browser. Now the problem with Karma is when I get to the last requirement I had, which is to rotate the screen. Karma simply cannot do that because I'm inside the browser. The browser cannot rotate itself. Like we don't have in Frontend ways to rotate the user's screen because it will rotate their hand. So many times with Karma, we got to the point where we just didn't have the right APIs. I will run a little forward because of time. Also with Karma, the issue we had is that the tests and the code run in the same environment, and they sometimes mess each other's context. And many times we had to add iframes to deal with that, and then iframes, the fact that we were using iframes created bugs that we didn't otherwise have. But Karma is pretty reliable. One thing we're using now is Puppeteer, Headless Chrome. Headless Chrome is quite new, and Puppeteer is a Node.js wrapper to it. It's very new, and we use it extensively after only 2 months, where it's stable. Puppeteer gives you a really nice API to handle Chrome from outside. In the test here, I can emulate portrait and emulate landscape. I can evaluate things inside the browser, like React Render. And it gives me a very rich API. However, it's not a test framework. Karma and JEST and Jasmine, Selenium are all test frameworks. Puppeteer is just a way to manipulate the browser. So we need to make it work together with other test frameworks, and everything is quite new in that world. So it's a middle ground between going full end-to-end with Selenium and doing more unit-style things with Karma. We can mix and match because it's not a testing framework, it's more like an API. For now, it's for Chrome only. What we saw with cross-browser testing is that many times, most things we do want to test only in one browser because of the high cost of testing on multiple browsers. And when we find edge cases that have browser-specific issues, we test those or regressions on cross browsers. That's a cost-benefit thing with testing front end. One thing with this is that it's not always that easy to debug because we have 2 JavaScript environments, one in Node, one in the browser. Sometimes we have to do like not so nice things like wait for several like in the code, wait for several minutes so that we can debug the other part of the JavaScript. We like it today, it's our new favorite, but maybe it's just because it's new and cool. We like new and cool stuff, and maybe some other new and cool things will come and we will feel different. It's still hard to say. Right now we like it. So if I summarize, JEST it doesn't test much in our experience, and it's for unit tests. Karma is reliable but limited. Puppeteer is our new favorite, and it's for integration tests. And we use Selenium for more end-to-end tests that go also to the browser and also to the server and try to do browser-specific things. One big takeaway I want you to take from this that I took in the last year is that a component is not a unit. Therefore, from that comes the problem of testing components with unit test tools. A component is something that's highly integrated with a lot of systems, usually. Like what I said, like the interactions, A/B testing, the user code for us, network services. So integration is a sweet spot to test components. Now, but we do want to have some unit tests. Yeah, with E2E tests, we cover more cross-browser corner cases. But we want to use unit tests for some things. If I go back to to the simple components behavior, what I like doing many times is create a little state machine that is pure JavaScript. Like here, I create a back to top button state machine. And I expose things inside that. I expose scroll to, I expose handle timeout, I expose the different screen orientations. This is a pure JavaScript state machine that has no React, has no DOM. It's totally pure function, and I can create unit tests for that as a state machine. It's very stable. You don't even need JS DOM because there is no DOM. Vanilla unit testing for that, and you can get all the permutations, and then your component, which is an integration, uses that internally. Thank you. Questions?
У кого вопросы, поднимайте руки.
First of all, thanks for great presentation.
Thank you.
According everything which we
Can you speak up?
What?
Okay, speak closer.
So everything was related with UI testing, as I understood. Do you test your controller part, MobX or Redux parts of your components? For example, actions, reducers, middlewares, sums, everything which created with control.
Yeah, so the way I look at controllers is that however much we can make them into pure JavaScript, frameworkless, like that state machine, the better they are for unit testing. When we have MobX in the picture, for me, it's already integration world. Like I would want to, with MobX, for example, I would want to test that a particular component didn't render. I would want to test an optimization like the component didn't render more than it should have. So there is an integration way to do that. For example, you can create a component that has a counter, and it renders a new number for each count, and we check the result of the component and see that it rendered the number of times that we expected to with the MobX optimizations. What we saw with the tests that try to understand too much about MobX internally is that we rewrite them with every refactor.
Okay. And concerning, so now the example was also linked with UI, where you control number of renders. And for example, do you cover, for example, with JEST your logic in front end part? For example, you have some complex logic which of actions, for example, and do you cover all these parts with tests or not?
We try as much as possible to cover also the complex logic. The way I see it with test-driven development is that the test-driven parts of the development should be the parts you expect. The happy and the sad flows, but the parts you expect, the bullet points you would get in the product, like it should close when the other panel opens. Definitely, I would write those as integration tests. Today I would write them in with Puppeteer, with Headless Chrome, with all the steps necessary, and I would have the tests look as much as possible as what the product owner defined. But that's where the bugs come from, so tests should come there as well. Yeah.
Okay, thanks.
Sure.
here I am. Does it work? Hi, thanks for your awesome presentation. I actually haven't tried the Puppeteer myself yet. So could you just clarify if you run the Puppeteer tests, not Selenium, but Puppeteer on production servers, or is it UI only tests? And if so, how do you mock the server if you don't use mocks in Spice?
So the integration tests we write with Puppeteer, some of them are more end-to-end-ish and go to our actual servers. And we have an internal way to run a site offline. So like I said, the Wix sites are actually JSON that's rendered into DOM. So we create offline versions of those JSONs and expect certain results from rendering them. So with a few bugs that we still have there, the Puppeteer tests are currently 80 to 90% offline.
So as far as I got here, it just works because you have this flow, here's the input and here's the output, and the result of work going there, right? So a second small question.
Yeah.
Have you completely refused from unit testing the UI components? What will my component do if I give it an empty array as an edge case, for example? Do you do this or not?
Not so much. I would rather test those things as part of a unit, like that state machine thing. This comes from a very old thing called the humble dialogue, very old software engineering technique to keep UI separate from the actual, keep the view logic separate from the actual view. So I would have maybe a processor unit that can deal with all the types of input, like the empty array and all those. And if there is an integration way to add an empty array, like you had to create labels, and you didn't create any labels, and you still clicked OK. If there was a way for the user to get to this point, then yeah, I would test it that way.
But if you do this in the integration test, you basically end up in a situation where this test covers millions of cases, whereas you could unit test 100 and 100, and then unit test the way just integration test the way it works together.
Yeah. So if I get to the scale problem, what I would do is take it out into a unit, but have this unit not be inside the component. Have a separate unit that has all the millions of permutation tests. And then the component itself will just hook to it. It will be like, here is your unit that handles all these types of data. Here is React. Now get them together. Very little code with a few integration tests to just make sure everything works.
OK, cool. Thanks. That's basically very much understandable. Thank you.
Sure. Thank you.
I have a microphone.
Yes.
It's working. Thanks for a good presentation. I'm really promoting this way of testing too, because yeah, you need to check the business requirements and not how the code works. I even work on end-to-end testing framework, Concept.js, which also uses Puppeteer. And my question about React testing, you mentioned that you didn't like this line browser URL open this page for component when you do Selenium testing. But how do you render this component when you're inside of Puppeteer? You still need to prepare the environment.
Right. And something about Puppeteer versus Selenium is that actually anything in this you can write in the other one. They're pretty interchangeable in terms of what you can do with them. We like using Puppeteer versus Selenium just because it's kind of better. No, just because it's more convenient. The API is more convenient. It's more stable. And the fact that it's for a single browser gives us a richer API. And what we do with those integration tests, as opposed to the end-to-end tests where we just write the URL, is that we inject the code.
So it's just empty page where you inject your code, you render component, and then you perform test.
Specifically, we have like a boilerplate page. We have like a page that has like an empty Wix viewer. And inside that Wix viewer, we say, okay, now add a component. So we have like this boilerplate for tests so that our test can cover only the little bit of test that it needs.
Okay, thanks.
Sure.
Hello. Thank you. Didn't you mention that you had some kind of visual testing at your description of your presentation? No?
Sorry?
You mentioned that you had you have some kind of visual testing.
Visual testing?
Yes.
Yes. So one thing we do for the Wix viewer as well is backwards compatibility tests for with images, image comparison. We do actual visual image comparison tests. At Wix, we have millions of websites built with the platform. Some of them were built years ago. And we use the image comparison to test that. That goes very far into end-to-end testing. It tests the whole site in different versions and compares images. We had when working at WebKit, we also had image comparison as tests. The problem with image comparison tests is that they're very rarely green. Every time we have an image comparison test, the build is red, and somebody needs to sit down and see if red means red, and what the failure actually are. Maybe somebody upgraded the Mac. You know, visual tests are again high cost, high value. I see actually high value in tests that are green, that can be green at some point. Something we do very, very new in my team, my team deals a lot with layout and responsive now, is that our visual test, instead of testing comparing images, we compare rectangles. Rectangles. No, we take a real website, we find all the different rectangles that are meaningful, that have an image or that have a color or that have a text. We do that just with regular web APIs. We find them and we compare them between versions. Sorry? In Puppeteer, in the headless Chrome. And then we check that and with a little delta, with a little epsilon, we make sure that things didn't move by more than 1 or 2 pixels. But sometimes we do want to change. We change from absolute position to flex some specific component. It will change by a pixel or a fraction of a pixel. We don't want the test to fail for that. An image comparison test will many times fail because of those things. We just want to check that things are kind of in their place. So rectangle tests are very useful for us, but also very new to us. Absolutely.
If anyone have a question? No? It's the last one.
Thank you for your talk. Pretty nice. And regarding Puppeteer, in my humble opinion, nowadays it has really verbose API. Do you use some kind of wrapper around Puppeteer or just clean Puppeteer?
We have our, let's say I hope for a good testing framework with Puppeteer. If I'm bored enough, I might just write one, I don't know. Or,
yeah, we heard of one framework. Is it around Puppeteer, yeah?
Yeah. But it's very, very new, I'm sure. Puppeteer is new. Yeah. What's the name of your framework? We're going to try it out. But for now, we have like our very specific wrapper to it. Like, one thing that's very important in tests, I didn't get to it because it's a short presentation, but we always separate the test from the driver. The test itself looks like the Jira ticket. It looks like browse here, wait a few seconds. It looks very like plain English. And then we have a driver that implements some of the functions and deal with the component. So we use very simple wrappers like that.
Do you have any plans to open source it?
Those drivers are very specific, but parts of what we do and how we do things, definitely. And the guy in my team that did that stuff keeps contributing patches to Puppeteer. We just found a few bugs, and if we see value in it open source wise, we definitely will. This stuff was written like in the last 2 months. Yeah.
Okay, thank you.